Objective 2, rationalizing the denominator. So 3 steps here. Simplify radical, multiply by 1, and reduce if possible. So first one. First, I have to look at this radical right here. See if I can simplify it. So when I'm simplifying this, the top number is not changing whatsoever. I'm looking at the square root 27, just like we did for objective 1. So this is 3 times 9, which is 3 times 3. I have a pair of 3's here. So now this becomes 1, 3 comes out, and I have 1, 3 underneath the root. Now, when you're dealing with the fraction, I can split this multiplication up. This is the same thing as 1 over 1. If I rewrite that so it's easier for you to see. Now this, remember you can always have a times 1 wherever you want, but this right here can simplify to be 1. 3 over 3 because there's all multiplication here, so this fraction simplifies to be 1 over square root 3. However, I did not rationalize the denominator yet. That was all the first step. I simplified the radical, and then I simplified the fraction. Now I have to multiply this by a fraction of 1. So when we're doing this, we always needed a pair of 2's. Okay? So we want to try to force this to have a pair of 2's underneath the radical. So I'm going to multiply this by 1. Remember, when you multiply anything by 1, it's always itself. So I want to multiply this by the square root 3 over the square root 3. Now, just like this, that's still just 1. Anything in the numerator and denominator of a fraction, that's still multiplying by 1. Now, if I multiply across, you have 1 times the square root 3. And bottom, when you multiply, you can multiply square roots together because they're both underneath the root. So this becomes the square root of 9. Now, you should know your perfect squares, but if not, you can always do your factor tree, and you would find that this has a perfect square of 3. So this becomes 1 square root 3 over 3. You cannot, repeat, cannot simplify something inside the root and something outside the root. These two are not the same. These two are not equivalent. You do not have to have this 1 here, but you sure can if you want to. That right there is my final answer. So for the second one, I don't have to simplify this radical at all because it's already prime factorization. So now I am going to my second step right away, multiplying the fraction by 1. So when I multiply this by 1, I want to think, what should I multiply this by so I can force a pair in the bottom? Our main objective is to get rid of this root in the denominator. We don't care if it's in the top, just like with this problem. We don't care if it's in the numerator. We do not want it in the denominator. So I have to think, what should I multiply this by? So in order to get a force a pair, I need to multiply by square root 2. In order to multiply this by 1, it has to be the same on top and bottom. I want you to pause the video and finish simplifying that now. Pause the video, finish simplifying. So when I multiply this is like 5 times square root 2. These two are not the same. Again, I cannot multiply across inside because this one's outside the root and this one's inside the root. So that's 5 times square root 2. On bottom, though, these are both inside the root. This becomes the square root of 4. The square root of 4 is 2. If possible, you would want to see now that the numbers outside the root could cancel, but I can't cancel anything here. So that's my final answer. So the last one. First, I want you to just try to simplify this radical first. Simplify this radical right now. Here, I could take out a 2 because there are a pair of 2's there, so that's where that 2 comes from. I personally like to move that negative out in front or on top with the number instead of having it out in front, and then I'm left with this 2 times 3 underneath the root. Now I have to think about my second step. Force the pair. So now I have to think, I have to multiply by the square root 6. Remember, I need to multiply by 1. So square root 6 times square root 6 is equivalent to 1. So right now I want you to pause the video and finish simplifying this as far as you possibly can. So when I multiply it across, I have this negative 1 times square root 6. That's where this comes from. I have 2. That's where this comes from. Square root 6 times square root 6. So 6 times 6 is 36. So that's where that square root came from, because you can multiply when they're both underneath the root. I can simplify this right here. Square root of 36 is 6. So now I can multiply these two together because they're both outside of the root. That's where this 12 comes from. Again, I cannot simplify a fraction that was something inside the root and something outside the root. So this right here is my final answer. And there you go, smarty pants. Look how smart you are. You did that easy breezy, beautiful. Have a great, grand, wonderful day.